This is a demonstration of Chebyshev's theorem. Chebyshev's theorem gives us a sense of how much or what proportion or what percent of the data will fall within a certain number of standard deviations of the mean. And it says that at least 1 minus 1 over k squared, that'll end up being a fraction, at least that fraction of the data will fall within k standard deviations of the mean. In order to use Chebyshev's theorem, we do not have to know the shape of the data. The data could be skewed or it could be symmetrical. It doesn't matter. For this question, we're going to assume that the mean is 80 and that the standard deviation is 10. And the question is asking us at least what percentage of the data will fall between 60 and 100. So I'm going to put the mean right here. And they're asking us at least what percent of the data will fall in this vicinity between 60 and 100. We're trying to figure that out. At least what percent of the data. The first thing that you need to do is you need to find the distance between the mean and the outer number that they're talking about. And that distance is 20. This distance on this direction should also be 20. But you're finding the distance from the center over to one of the edges. Then you take that distance and you want to see how many standard deviations that is. So 20 divided by 10 is 2. That's 2 standard deviations, and that's the k in Chebyshev's formula. It's the number of standard deviations. So for this particular problem, you'd put a 2 where the k is in the formula. So the fraction of the data is 3/4, and 3/4 is 75%. So what we're saying here is that if the mean is really 80 and the standard deviation is 10, then the answer to their question is at least 75% of the data will fall between 60 and 100. It could be more than that, but 75 is the minimum percentage. This question also is asking this: if the mean is 80 and the standard deviation is 10, at least what percent of the data will fall between 65 and 95? So again, you should find the actual difference between the center, this is the mean, and one of the outer numbers, this is 15. This distance will also be 15. Then take your 15 and see how many standard deviations that is. The standard deviation is 10, so this is 1.5, 15 divided by 10. So the k is a 1.5 in this question. So you go like this. You put the 1.5 right there in the Chebyshev's formula. And then I'm going to come over here and show you on the calculator when this is a number that we can't do in our head. We can do it like this. I'm doing 1 minus 1 over 1.5 squared. The decimal is a 0.5555 repeating, so you could maybe round that to about 56%, you know, it's about. So the answer to this would be at least 56% of the data would fall between 65 and 95.